Hey there, folks, it's Mr. Young, and I'm here to tell you the thrilling story of the ice cube who melted. Yep, that's right. Thank you for your sacrifice, Ice Cube. Okay, so just a reminder, the boiling point of water is 100 degrees Celsius. The freezing point or melting point of water is 0 degrees Celsius. Freezing point and melting point are always the same temperature. Below zero, it's frozen. Above zero, it's melted. So freezing point and melting point are the same temperature. This ice cube is at about minus 15 degrees Celsius. That's about the temperature in your freezer. Okay. And so we got this solid ice cube. We've just taken it out of the freezer. It's at minus 15 degrees Celsius. We just have one phase of water here. It's ice, H2O solid, below 0 degrees Celsius. As heat from the air enters that ice cube, eventually the ice cube is going to warm up. It's going to warm up until it reaches 0 degrees. When it reaches 0 degrees, it starts melting. And now we have ice at 0 degrees Celsius and water at 0 degrees Celsius. They can't get any warmer until all the ice melts. So that ice cube is going to continue to melt, and notice it's staying at 0 degrees Celsius. The solid ice and the liquid water both stay at 0 degrees Celsius until the ice cube entirely melts. So we have two phases now, where we had one when it was below 0 degrees. When we're at 0 degrees, at the melting point, we have two phases present. Then when all the ice cube has melted, we're back to one phase. We're back to just liquid water, and now we're above the melting point. We're at about 1 or 2 degrees. And now, if we want to heat up this water, let's see what happens as it heats up and heats up. Let's turn on the hot plate, okay? The water can go from 1 or 2 degrees up to about 99 degrees, and it'll stay as one phase. It'll stay as liquid water. So it's liquid water, one phase, all the way up to 99 degrees. When it reaches 100 degrees, that water is going to start boiling. And when it starts boiling, now we've got two phases again. We've got liquid water and we've got water vapor. And they are both going to stay at 100 degrees Celsius. It's going to stay at that boiling temperature until all the water boils away. So, okay, it's heating, heating, heating. Eventually, all that liquid water is going to turn to water vapor. The water vapor that floats away will have a temperature over 100 degrees Celsius. And if we could trap the water vapor, we could heat it up to over 100 degrees. We could make superheated steam. But again, now we're back to just one phase. When we're over the boiling point, we're at one phase, but when we were at the boiling point, we had two phases. Okay, so let's go through a quick recap. At 15 degrees Celsius, we're below the freezing point of water. When that ice cube warms up, it reaches its melting point. Okay, now we've got ice and water at 0 degrees. The ice and water stay at 0 degrees as that ice cube is melting, and they don't go above 0 degrees until all the ice cube is melted. Once all the ice cube is melted, the temperature can go above zero. Okay, and if we heat up that water, the temperature can rise all the way up to 99 degrees or 99.9 degrees. Okay, as a single phase. When it reaches 100 degrees Celsius, it will start to boil, and now we'll have two phases again. Okay, we'll have liquid water and water vapor, both at 100 degrees. Then what'll happen is all that water will be evaporated. Now we can have water vapor, and the temperature can actually go over 100 degrees, and we're back to one phase present. So at 100 degrees, we had two phases. At 0 degrees Celsius, we had two phases, but everywhere else, there was always one phase present. Here's another way to look at it. This is what's called a heating curve. It may look a little weird, but you'll learn about these this week. Okay, it's just showing that we're adding heat over time to some substance. In this case, it's water, and we're showing the temperature. Okay, so here is ice, the solid ice cube. Here is when it turned into a totally liquid. Here is when it eventually all turned to gas. Notice that when melting was happening, we had a solid and a liquid present. But before melting happened, the temperature was rising until it reached that melting point. While it was melting, it stayed exactly at 0 degrees. We had solid and liquid until all the solid melted. Then we had a liquid present, and we warmed up that liquid water from 1 degree all the way up to 99 degrees. When we got to 100 degrees, boiling started to happen. And when boiling was happening, we had two phases again. We had liquid water and a gaseous water. When all that liquid water boiled and turned into a gas, then the temperature was able to rise again. So on a graph like this, on the diagonals, you always have one phase, solid, liquid, then gas. At the melting point and at the boiling point, you have a flat part of the curve and you can have two phases present, solid and liquid while it's melting, liquid and gas while it's boiling. Okay, we'll learn more about these graphs and these heating curves and cooling curves also later this week. All right, let's check yourself. Some things you should have learned from this little video. All right, what is a possible temperature for this beaker of liquid H2O? Hit pause and try it. Okay, if it's a liquid, it's got to be above the freezing point, above 0, and below the boiling point, below 100. So 15 degrees Celsius and 99 degrees Celsius are both possible temperatures for a beaker of liquid H2O. What is a possible temperature for this beaker of boiling H2O? If it's boiling, hit pause. Okay, if it's boiling, it can only be at 100 degrees Celsius. That's the boiling point of water. How many phases will be present if you have H2O at 23 degrees Celsius? Hit pause. Okay, at 23 degrees Celsius, we're above the melting point or freezing point, and we're below the boiling point. We'll only have one phase present at 23 degrees Celsius. What is a possible temperature for this melting ice cube where solid water and liquid water are both present? Hit pause. Okay, that has to be happening at 0 degrees. That's the melting point or freezing point, and that's when you've got two phases present. If it was above that, it would be all liquid. If it was above the melting point, you would have only one phase. You'd have all liquid water. How many phases will be present if you have H2O at 100 degrees Celsius? Hit pause. Okay, 100 degrees Celsius is the boiling point of water. That's when you've got liquid water present and gas vapor present, and they're both at 100 degrees Celsius. Okay. What is a possible temperature for this solid H2O that has no signs of melting? Okay, it's solid H2O and it is not melting. Hit pause. Okay, if it's not melting, it has to be below 0 degrees, -5 Celsius. If a little bit of water has started to appear, if they're starting to melt, then those ice cubes must be at 0 degrees Celsius. Okay, how many phases will be present if you have H2O at 0 degrees? See, 0 degrees, hit pause. Okay, we'll have two phases. 0 degrees is the melting point or freezing point of water. So if you're at 0 degrees, you have to have both liquid and solid water. Just like when you're at 100 degrees, you have to have liquid water and gas phase water or water vapor. All right, again, on this heating curve for water, as we add heat over time, the temperature will rise. We can heat up a solid, heat it up, heat it up, heat it up, heat it up, and eventually it'll turn into a liquid, and eventually that'll turn into a gas. But when melting is happening, you'll have two phases present, and the temperature will stay constant. And when boiling is happening, you'll also have two phases present, and the temperature will stay constant. The temperature can only rise when you have one phase, a solid, or one phase, a liquid, or one phase, a gas. When melting and boiling are happening, you can have two phases present, solid and liquid for melting, or liquid and gas for boiling. Okay, folks, thanks for watching, and get back to your HyperDoc.